Welcome to this edition of India Means Innovation, where we discuss the technologically complex innovations coming out of India. Today we have with us Mr. Ritesh Tyagi, VP and Global Head of the Semiconductor Business of Wipro. Wipro is a global pioneer from India in the technology business. Welcome, Ritesh.
Thanks for having me, Aditya.
Ritesh, let's get into the major innovation your team has created. You have created an agentic AI for semiconductor design. Is that right?
That's correct.
Agentic AI, how is it different from the normal ChatGPT AI that we talk about?
Very simplistically, if you look at that, we've been using machine learning for a long time, where there was a particular task machine was been performing. Now with agentic AI, we can create these agents who are actually doing multitude of these tasks. They are self-learner, and also they're actually producing the results that is tremendously saving time and efficiency and productivity overall.
So does it mean that an agent mimics a team of human beings? It does a chain of tasks instead of doing one point task.
So this is where the whole attempt for this AI initiative is to perform certain tasks repeatedly, more efficiently, and of course where a lot of human intervention was required, that can be eliminate that. And where humans can go and or human brains can be utilized for more complex tasks and algorithm later on. Now, with this agentic AI, we can improve the efficiency, reduce down the human interventions, as well as substantially bring our workforce knowledgeable much faster as opposed to what we have been seeing in the past.
Semiconductor design itself is an extremely complex thing. It requires heavy-duty brains of human beings to do it. Now, when you replace it with your agentic AI, what is the kind of productivity we are talking about? If it took, let's say, 20 human beings to design a certain chip, with agentic AI, what does it come down to?
Let me respond a little bit longer in this because it's a very complex question. Of course, everybody would like to see what's a dollar saving happens. But actually, we are looking at efficiency in totality. So first, if this whole semiconductor design cycle is quite complex, as you already said. And the number of engineers who are coming out of academia takes time to learn, and a lot of learning cycle has been consumed. For example, if you look at it in old days where we were writing the code in assembly language, then higher level language appeared, and then the program became much easier and faster actually. Very similar in the semiconductor design, we are still in an age where engineer learns on the job, and it takes 1 year, 2 year, 3 year, 4 years in fact. Now, with the help of agentic AI, first we have to improve this learning curve dramatically to our young graduates who are coming. That's the one part. Now let's talk about the overall design cycle. So in semiconductor, you start with the RTL design, then you go to verification, you have PD, DFT, and test, etc. In each stages, we are creating different agents who are going to run on the existing backbone or existing tools flow, and ultimately going to produce mundane work, which is repeated tasks actually much faster. So overall efficiency gain, we are looking at around 20 to 50%. Now, this is a major number, 20 to 50%, and I'll tell you why is that so. But in summary, the efficiency gain would be dramatically that we can see with this agentic AI effort.
One part is the efficiency gain. Is there a second angle to this in which the agents are going to create new ways of designing the chip, new approaches of designing the chip that, let's say, cuts down the power consumption, better design itself? Are you looking at that?
Actually, that's an interesting concept. So answer is yes. And let me tell you how. So today, the semiconductor design cycle, knowledge is based on how many different designs you have done in your career and how many data sheet that you can read, what's your capacity is. It's a daunting task, and a lot of tribal knowledge has been kept within engineer to engineer to engineer, actually. Now with this agentic AI, there are many design rules that an engineer have never thought about it, or he has probably not attempted because the knowledge was not there. That can be brought onto the forefront with the help of these agents. So these agents can go and scan through thousands of pages of data sheets, thousands of variation of design rules, and then can offer to the engineer that, hey, this is the way we can design it where the chip size could be smaller, power consumption can be reduced down, the overall floor planning of the chip can be optimized, and all these options would be on the fingertip of an engineer.
So in the early days of AI, there's the legendary move 37 aha moment in AlphaGo, right? In your experience in creating these agentic AIs for designing the chips, have you experienced the move 37 aha?
Every experience is aha moment in a sense that whatever we make improvement, I'm not sure whether it's precisely equal to that aha moment, but when we started doing this within our team over here, we saw that, especially in design verification, which is where we need largest number of engineers. And there will always be scarcity on the planet. And when we started looking at then on the different cycle of verification, we started seeing the results where it is coming from 20 to 40% of improvement. That was pretty substantial. And initially I didn't believe it. I said, well, can we verify it as well? So when we able to verify our result using a particular data sets, that was a very satisfying moment. That means it can be done.
Can you take us through what does it take from a technology point of view to create an agent?
Quite complex, actually. What approach we have taken over here is that let's build this as a grounds up. Means it is not an agent sitting on top of API, but it is actually interacting the current tool flow directly. So for that, we have to write the code at the foundation level for these agentic AIs, and so that it should be very efficient. Now, second problem is that I can build a lot of agents, but if they use a lot of compute power to run the inference and training, then purpose is defeated. So we need to really build these agents very efficiently, and that's where the major differentiation that we are bringing to the table.
When humans were designing the chips, as many of them still are, there was a generational improvement in the way designs happened. Now, when agents are going to do the design, how do the agents get better? Do they train themselves to be better, or are there other humans which are going to make them better?
Well, they are self-learner. So it's all about the whole IPs around the prompt engineering, that how we define those prompts, which will tell the agent what to do, what to look for, and then really keep that a memory footprint where they are self-learning, wherever they see errors and wherever they are pointing out the issues. In the next version, they are constantly crawling and through their memory lane and doing the self-improvement. So these agents are definitely self-learner. That's the whole idea about it. Now, whether human intervention is required or not, yes, it would require in the beginning, because there are two reasons. One is we have to build confidence as well, that semiconductor chip is not the typical web software development, where you can easily write 2 lines of code, change it, and everything will fine. Here is a tens of millions of dollars on the stake. Once you leave your GDS2 to the fab, basically all bets are off after that.
Right.
So it's all about how people will feel comfortable during this design process, and then more and more agents are producing predictable results. I think human intervention will start going down and down and down.
And this entire agentic AI has been conceptualized, designed, and built out of India by your team.
Precisely, Aditya, and I'm very proud of that. The business unit we set up over here, Turnkey Silicon Business Unit, in order to encourage team members to build innovation or do innovation without being afraid of failure, we have to create this kind of a group. This group is actually designing the full spec to GDS2 silicon design for various customer actually. And this Agentic AI initiative also started from this group because they have a complete responsibility of designing the silicon from spec to GDS2.
This is a great example of India means innovation. Thank you.
Thank you. Pleasure.